A servlet, by its very nature, is designed to run in multiple threads. Every client who starts a request to the server will get its own threaded copy of the servlet. This procedure is handled by the servlet itself, and it requires very little in the way of effort on your part. Parallel access procedures are mainly important for controlling access to shared resources, such as external databases. When multiple threads access the same shared items concurrently, there is the potential for conflicts and non-deterministic behavior. In order to ensure that your servlet runs smoothly, you have to synchronize all access methods. There are three main places that concurrently accessed resources might be stored. Multiple threads might access objects stored in a web context, which is held in common for all threads of the servlet. Meanwhile, multiple web components might also access data stored within a session. Finally, multiple threads within a web component might need to access the instance variables of that component concurrently. If you don't take these situations into consideration, your servlets may run into conflicts as multiple threads or web components attempt to access the same objects at the same time. Let's take a look at the servlet, just to get an idea of some of the parallel access procedures that we could use and how they could help make sure that our servlet doesn't run into conflicts. The simplest way to solve access problems is to prevent multiple threads from executing concurrently. This can be done by having your servlet implement the single thread model. So we would change the implementation here to single thread model. The single thread model has no methods, but it serves as a marker to the processor that it should only handle one request at a time. The servlet container will either have just one instance of the servlet and only allow consecutive access, or it will maintain a pool of servlet instances and assign them as needed to new requests, but never assign more than one request to a single servlet instance. Since this interface has no methods, adding it to the servlet is easy. We can take the servlet created in Chapter 1 and just add the implements single thread model to the beginning. Obviously, there are a number of disadvantages to this approach, most notably that you can only respond to one request per servlet at a given time. Moreover, this doesn't solve all of the thread safety issues. Session attributes and static variables in your web context are not protected, so if you have a pool of servlets responding to requests, then they could potentially access those variables in a non-deterministic fashion. A better approach is to use blocking on only the parts of the program that could lead to problems. For this, we can use the synchronized method descriptor. This descriptor essentially warns Java that the method might be executed by multiple threads simultaneously, so it should check for potential problems. Notice how on the methods that we created earlier for increment, decrement, and getCount, because they are specifically designed to be accessed by multiple servlets and multiple threads, all of those methods are synchronized. Whenever a synchronized method for an object is running, all other threads that invoked synchronized methods for the same object will stop and wait for the first thread to finish. Additionally, as soon as the synchronized method exits, it will immediately inform all other threads of changes to the object before they have a chance to run on that same object. Synchronization is not a perfect solution, and it can lead to issues like deadlock, where every thread is blocked and none can execute, starvation, where one or more threads are unable to access a shared resource for long periods of time, and live lock, where two threads are dependent on one another in such a way that they get stuck in a loop. Dealing with situations like these is a complex art, and we'll go into more detail about that later in this chapter. For most purposes, though, it will be sufficient to add synchronized to each method that accesses external variables or databases.